Good morning everyone. This is our third video on number system. I hope you have gone through our first two videos. If not, you can check the description section for the link to those videos. Now, decimal number system. We have discussed what is decimal number system. Here, let us consider a fractional decimal number. So, let us consider a fractional decimal number 49.12. The decimal point separates the whole number from the decimal digits on the right. So you can see here this decimal point separates the whole number 49 from this fractional part. This decimal point separates the whole number 49 from the fractional part, that is 1 2. You can also see that 49.12 can be written as 4 into 10 to the power 1 plus 9 into 10 to the power 0 plus 1 into 10 to the power minus 1 plus 2 into 10 to the power minus 2. Why so? Because the position of 4 is 1, the position of 9 is 0, the position of 1 is minus 1 and the position of 2 is minus 2. Here you can see that we have shown you the positional values. These are not the positions but the positional values. So the positional value of 4 is 10 to the power 1. The positional value of 9 is 10 to the power 0. The positional value of 1 is 10 to the power minus 1 and the positional value of 2 is 10 to the power minus 2. So this gives us 49.12 is equal to 4 into 10 plus 9 into 1 plus 1 by 10, because 10 to the power minus 1 is 1 by 10, plus 2 by 100 because 10 to the power minus 2 is 1 by 100. So this is equal to 40 plus 9 plus 0.1 plus 0.02. Then let us go through the binary number system. So let us consider a fractional binary number 1011.0101 base 2. We already know what a binary number is. You can go through our previous videos if you don't know what is a binary number. So the binary point, so this point separates the whole number part from the fractional part. So this is the whole number part and this is the fractional part. So this binary point separates the whole number part from the fractional part. Coming to octal number system, let us consider the fractional octal number 1267.12. We also discussed what an octal number is in our previous videos. The radix point separates the whole number part from the fractional part. This radix part, so whatever is before the radix point is the whole number part, and whatever is after the radix point, that is the fractional part. Similarly, let us consider a hexadecimal number A65.C2, and you can see that we have this hexadecimal number written over here. So the positional value of A is 16 to the power 2, the positional value of 6 is 16 to the power 1, the positional value of 5 is 16 to the power 0, the positional value of C is 16 to the power minus 1, and the positional value of 2 is 16 to the power minus 2. Now, binary number system to decimal number system. So how will we convert binary number system to decimal number system? So let us consider a binary number 1011.0101 base 2. So as you can see, the position of MSB is 3 and the position of LSB is minus 4. So here this one is the MSB and this one is the LSB. So what we need to do is we need to multiply 1 with 2 to the power 3. Why 2? Because the base is 2 in case of binary numbers. And why 3? Because the position of the first one, that is the MSB, is 3 plus 0 into 2 to the power 2. And in a similar fashion, we have to add 1 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4. So this 1 into 2 to the power 3 gives us 8. 0 multiplied by any number is 0, so this value becomes 0. 1 into 2 to the power 1, this is 2. 1 into 2 to the power 0, this is 1. Again 0 multiplied by any number is 0, so this is 0. Then 1 into 2 to the power minus 2, this is 0.25. Again 0 multiplied by any number is 0, so this is 0. And finally 1 into 2 to the power minus 4 is 0.0625. When we add all these, we get 11.325. So 1011.0101 base 2 is equal to 11.3125 base 10. Now we will convert a decimal number to binary number system. So let us consider a decimal number 47.598. Here we have two parts. One is the integer part, that is 47, and the other is the fractional part, that is 0.598 or just 0.598. We have to treat this separately. So for the integer part, we have to divide it by 2 as discussed in our earlier videos. So when we divide 47 by 2, we get 23 as quotient and 1 is the remainder. Similarly, when we divide 23 by 2, we get 11 as quotient and 1 is the remainder. Again, we divide 11 by 2 and we get 5 as the quotient and 1 is the remainder. Again, we divide 5 by 2, we get 2 as the quotient and 1 is the remainder. Again, we divide 2 by 2, we get 1 as the quotient and 0 as remainder. And when we divide 1 by 2, we get 0 as quotient and 1 as remainder. So 47 base 10 is equal to 1011 and again to 1 base 2. But in case of fractional part, instead of division, what we need to do is we need to do multiplication. So 0.598 into 2 is 1.196. Here we will select the values that is before the decimal digits. So the value before decimal digit is 1, so we will select that 1. Again, we will multiply 0.196. We will remove the 1 that is written in red color in the fractional part. So here you can see that we will not select this one. So 2 into 1.96. So 2 into 0.196, I am sorry, 2 into 0.196. This gives us 0.392. Again we will select this 0 and again we will do 2 into 0.392. So this gives us 0.784 and here again we will select the 0. We are not proceeding further as we are taking 3 digits after the binary point. So 0.598 base 10 is equal to 0.100 base 2. So when we add both these things up, 47.598 base 10 becomes 101111 dot or binary point 100 base 2. So this is it for today. Thank you.